Hey guys, it's Stephen Gates here with yet another video to help you become a confident PLC programmer and a confident automation professional. So this video is all about SCADA systems. The SCADA acronym stands for Supervisory Control and Data Acquisition. So I get a lot of questions about SCADA, and so I wanted to make a video about it to answer some of those questions, give you a broad overview, and show you how it connects to PLCs and HMIs. So in the automation world, there is a lot of confusion over the different types of automation systems and controllers and all the acronyms that people throw out there. They just make it even more confusing, especially for beginners. So hopefully this will clear up some of that confusion. Some of the acronyms that you've probably heard are PLC, PAC, DCS, HMI, MMI, OIT, and SCADA. So hopefully this video will simplify some of those acronyms for you, especially in regards to how PLCs and HMIs fit into SCADA systems. So first of all, let's discuss the relationship between SCADA, HMI, and PLC. In this image here, this is representing a SCADA system. We have a really simple example of what a SCADA system might be, how it might be laid out as far as the different components. So basically we have multiple PLCs, Control Logic's Allen Bradley PLCs here, and then we have multiple HMIs. These are Panel View Plus displays, and we have some random industrial equipment. So what we're going to look at here is, let's just start with one of these machines. As you can see, this kind of looks like a robot, and there's the PLC controlling it. And then we have a small HMI touchscreen that allows operators to monitor and control that piece of equipment. So when you go into a plant environment, if you haven't been around a lot of factories and automated plants, what you'll see a lot of times is that each piece of equipment has its own PLC controller and operator interface HMI touchscreen mounted near the piece of equipment. And that controller, that PLC controller, and that HMI are dedicated to that piece of equipment. So that's what we are trying to show here. This is kind of a certain equipment area. It's got a dedicated controller and HMI just controlling that machine. Next, we have another section of equipment here. It looks like some water or oil pumping, purification, or transfer station. I have no idea what it actually is, but that's what it looks like to me. And again, it has its own PLC and HMI that control and monitor that automation system or that equipment. And then finally, a third piece here looks like some sort of pressurized gas tanks, their own PLC and HMI. Now, I've showed this in I've shown this all in a very simplified format just to keep this lesson short and also to avoid confusion for you. But basically, we can see that all the PLCs are networked together. So this dark line represents the network that they are all connected on. And they're communicating with this main SCADA HMI system. So HMI again stands for Human Machine Interface. So this would be like in the operator room, the main control room where the operator sits in a plant, and he can monitor and control things in the plant and in the process from that one central location. So as you can see, SCADA systems aren't just certain electronic devices. That's what I think some people get confused. They think SCADA system is like a PLC, like you have a PLC controller and then you have a SCADA controller. That's not what SCADA is. More of a architecture. So it's multiple devices working together, and it usually is summarized in one central HMI screen where the operator works. So I put two screens because a lot of HMIs, they'll use two different displays so they can show more of the plant, but it would all generally be the same application. Okay, so let's talk about supervisory control. So SCADA stands for Supervisory Control and Data Acquisition, or Data Acquisition. And it's not a certain device. SCADA isn't a device, but rather a collection of devices and networking, all designed to centralize monitoring and supervisory control of a plant, process, system into one location, like these HMI screens. So supervisory control is kind of different than typical control provided by a local PLC on a machine. When we were talking about the equipment control, so the control that comes with the equipment, so a piece of equipment will come with its own PLC system built in to automate it. We were talking about the PLC or PAC that would control everything in that piece of equipment or machine. So in a tank transfer system, for example, the PLC might control turning on and off multiple pumps. So like in this example here in the middle, to get liquid from one tank to another would probably involve turning on and off different pumps, opening and closing maybe 20 different valves, turning off and on indicator lights and alarms as necessary, and the HMI might give the operator the ability to jog a motor or open and close each individual valve for things like testing or troubleshooting or cleaning purposes, things like that. So basically the idea is the controller, the PLC, and the HMI that's dedicated to that piece of equipment has lots of control, lots of monitoring. It gets down into the details. However, generally speaking, the SCADA supervisory control is not going to be as granular, not going to be as detailed. It's going to be more of a high-level control. For example, the operator could choose to start liquid transfer, which would then send a signal to the machine's PLC to start the transfer process. The transfer process itself may have several steps, such as open valve 1, start pump 2, close valve 13 out there, wait for 3 minutes until there's a low level in the tank, and then stop pump 2 and close valve 1, things like that. But from the SCADA system, obviously the operator is just doing kind of one big function, one operation, and all those other things. That one single control request is sent to this local PLC, and then this local PLC performs the transfer. So hopefully you get the idea. That's not to say that SCADA systems don't have the ability to do single functions like open that valve. You can't do that from the SCADA system. I'm not saying that, but generally speaking, the SCADA system is designed to just be supervisory control functions that aren't as granular. So next, we are going to take a look at a soft drink factory SCADA system, and this actually comes from Factory Talk View SE. It's a built-in sample application called Instant Fizz SE, and it's pretty cool. So I'm going to pull that up here. So I've got this open here, and it's not running or anything. We're just kind of looking at it in the design time. But this is the plant overview screen here, and as you can see, this display shows a bunch of different equipment that apparently all works together to make the soft drinks and bottle it up and then package the filled bottles or cans or whatever they are putting the soft drink in. And there are additional screens. As you can see, there's actually quite a few additional screens that have been created for this project, this sample project. So one of the ones we could look at here is the rapid mix overview, which is here. And so this is a portion of the plant that you can kind of drill down into and see what's going on with that process. And you can see supervisory control options like start stop here for the rapid mix system. And then some of these other systems like filling, let's see if we can check that out as well. So you can see the filling system. We drill down into that and see it here, and see you've got start and stop control on this screen here for that portion of the system. So again, start, stop might mean you're basically just sending one signal to that PLC and the PLC does the rest. So that's an example of supervisory control. So another important part of a SCADA system HMI is the alarms. Alarms are very important in automated systems, since the operator is normally just sitting back monitoring the screens. He needs to know if something in the automated plant has failed or is an alarm. So for example, if the level of soft drink liquid is getting too high in one of these tanks, if we go back to the plant overview, like one of these tanks, I assume there's soft liquid in these tanks that's being processed. If it was getting too high, that could mean that a pump or a valve isn't working properly. So often tanks will be equipped with level sensors to detect the liquid is getting too high or too low, depending on the purpose of the tank. But almost always you would want to alarm if a tank is getting too high. Also, in the packaging area, let's say there was too many packages on the conveyor belt. So if somehow these weren't spaced out so nicely like this, if one of them got stuck in there or here, it might mean that there was something stuck, maybe a sticking point on the conveyor or a motor, or something was jammed up. Could be a whole number of things. I am not in the packaging industry, but I don't think it's hard to imagine that there could be a whole host of different things that would cause a problem like that. And then maybe it would alarm if there was a box missing. You could think of a variety of different anomalies that you would want to alarm on to stop the process, or at least alert the operator that something was off. So then if we look at alarms, so then the operator would see alarms on this alarm screen and he would be able to address them as needed. You can see that there's even some alarms that can be simulated here, such as a low limit, high limit, high limit, so on. So in summary, SCADA system is a supervisory control and data acquisition system that collects data from various controllers, such as PLCs or remote terminal units, RTUs, which we didn't really talk about, but basically they're like PLC I/O racks, and they may not be called PLCs, but they do basically the same thing. And it combines that data from those various controllers into a centralized system, such as the HMIs we discussed early in this lesson. And it gives the operator the opportunity to respond to alarms, monitor the system, monitor system variables, and or perform high-level control actions such as starting or stopping a machine or process or jogging a motor and so on. Okay, so that's it for this video. I hope you found it helpful and that you've learned something about SCADA systems. Learning SCADA systems requires learning about each individual part of the SCADA, and PLCs and HMI are almost always integral parts of a SCADA system. So people ask me sometimes, do you have any courses on SCADA? I don't. But if you learn PLCs and HMIs, you're well on your way to understanding SCADA systems. And it's just a matter of learning the particular software and technology that's used in whichever SCADA system you're dealing with. So if you're ready to get confident with PLC and HMI programming with Allen Bradley Rockwell products, then check out our PLC training membership called My PLC Training Academy. And that's it for now. We will see you in the next video. Thanks for watching.